Okay, we're on section 7.5, and our learning goals for this section is for you to be able to solve radical equations and find extraneous solutions. A radical equation is an equation with a variable in the radicand or a variable with a rational exponent. So when we talk about the radicand, that's this right here. That's our radicand. When we have a variable inside of it, that's a radical equation. Or if we have a variable with a rational exponent. So today we're just going to talk about that first kind, when you have the variable inside a radicand. And when we do these, sometimes we might get extraneous roots. That occurs when you raise both sides of the equation to a power. And we will learn what that means. And we'll highlight some steps once we start to some more difficult problems. So the easy example, again, if we have the square root of x, in order to get rid of that square root, we're just going to take it to the second power. And when we do it to one side, we have to do it the other side. So x equals 36. Pretty simple, right? Same thing for this example. Even though we have x plus 5 underneath there, it's the same thing. We're just taking it to the second power. So that means we got rid of the radical. So x plus 5 equals, and again, 7 squared is 49. Now we just got one more step. We subtract 5, and x equals 44. In our next example, you'll notice that we have something under a radicand and something next to it. So the steps for this. First thing you want to do is get the radical by itself. So this plus 7 is not under that radical, so I want to get rid of that first. So I would have x minus 4 all by itself on the one side of the equal sign, and then 10 minus 7 is 3. The second step is the same thing we did on the previous two. Square both sides. And we square it because in this particular problem we were getting the square root. So that's the second step. We square both sides, and we get x minus 4 equals 9, because 3 squared
Kyra Owens,
is 9.
please come to the main office, please.
The next step,
Kyra Owens, to the main office,
we're going to
please.
solve for x. If we have x minus 4, we have to add 4 to both sides. X equals 13. And then the last thing that we would like you to do is check. Does this one work? Check it. So we're going to plug in 13 to our original problem. So the square root of 13 minus 4 plus 7 equals 10. Then we solve it. So what is the square root of 13 minus 4? That's the square root of 9 plus 7 equals 10. Square root of 9 is 3. 3 plus 7 equals 10. 10 equals 10, and this problem checks out, and we're done. Hope you wrote these 4 steps down, because we're going to use them on the next problem. Again, we want to get the radical by itself. There are 2 things here that are outside of the radical that we're worried about, the 4 and the 2. We want to get the stuff furthest away first. That's the stuff that we're adding or subtracting. So 4 plus, this is a positive 4. So I'm going to subtract 4 from both sides. And I end up with 2 square root of 3x minus 2 equals 8. The next thing I'm going to do is I'm going to get rid of that 2 out front, because it's multiplication. I get rid of it by division. And then I have square root of 3x minus 2 equals 4. Now, we're back to the point where we just have a radical and we want to get rid of it. So second power. So now we have 3x minus 2 equals, and 4 squared is 16. Basic Algebra 1, we want to solve for x. So I'm going to add 2. 3x equals 18. I divide by that 3. X equals 6. Last step, check it to make sure it works. So I do 4 plus 2 times 3. And in here, my answer was 6. So I put in a 6 minus 2 equals 12. So, 4 plus 2, we do the 6 times 3, which is 18 minus 2, equals 12. 4 plus 2, the 18 minus 2 is 16, equals 12. In some of these problems, you might be able to do parts of it in your head. The square root of 16 is 4, so I have to do 2 times 4. And 2 times 4 is 8. And yes, 12 equals 12. That one checks out. Now, when we have a variable on both sides, that's where we're going to end up checking for extraneous solutions. But first things first, get it by itself. So, square root of x minus 3 equals x minus 5. We're going to square both sides just like we have been all along. So x minus 3 equals x minus 5 times x minus 5. X minus 3 equals, and when we FOIL this, we get x squared minus 5x minus 5x plus 25. We combine our like terms. X minus 3 equals x squared minus 10x plus 25. To solve this kind of problem with x on both sides, we're going to set the whole problem equal to 0. So I need to get rid of the x and get rid of 3 so that we end up on that side with just 0. So I'm going to put that x under here and that 3 under here. X squared. Then we have negative 10x minus another x gives us negative 11x. And we add 25 and 3 and get 28. So now we're just going to factor to solve this. 0 equals, and we set up our parentheses. What multiplies to 28, but adds to negative 11, negative 7, negative 4. That's what works. So I do x minus 7, x minus 4. We set those equal to 0, and x equals 7, x equals 4. But we have to check both answers. So, we go up to our original equation. And we had checked, and we had said that x equals 7 and x equals 4. We'll see which one works. We're going to plug it in. So we'll start with 4. Square root of 4 minus 3 plus 5 is 4. 4 minus 3 is 1. So square root of 1 plus 5 equals 4. 1 plus 5 equals 4. 6. Well, that doesn't work, so let's try 7. Same process. Square root of 7 minus 3 plus 5 equals 7. Well, 7 minus 3 is 4. Plus 5 equals 7. Square root of 4 is 2. Plus 5 equals 7. 7 equals 7. That one works. Our last example that we're going to cover, same type of situation. We're getting it by itself by subtracting 3. So we have the square root of 5x minus 1 equals x minus 3. We're going to square both sides. So 5x minus 1 equals x minus 3 times x minus 3. 5x minus 1 equals, if we were to FOIL that out, we'd get x squared minus 6x plus 9. We're going to move these things to the other side. So we're going to put it right under the like terms that they would go. So 0 equals x squared minus 11x plus 10. All right. Factoring again, what multiplies to 10 but adds to 11? That would be negative 10 and negative 1. Negative 10 times negative 1 is positive 10, but they add to negative 11. So that means x equals 10 or x equals 1. And we have to figure out which one works. We go up to our original equation. We have x equals 10 or x equals 1. We plug in 1, you get 5 times 1 minus 1 plus 3 equals 1. You plug in 1 for x. So 5 minus times 1 is 5. So that's square root of 4 plus 3 equals 1. Square root of 4 is 2. 2 plus 3, well, that's 5, and it doesn't equal 1. So we know 1 doesn't work. Try the same thing again, and we use 10. Square root of 5 times 10. Oops. I'm running out of room on this side. Square root of 5 times 10 minus 1 plus 3 equals 10. So that means we're doing the square root of 50 minus 1 plus 3 equals 10. Which means square root of 49 plus 3 equals 10. And 7 plus 3 equals 10. And 10 does equal 10. So this one works. And that is your answer. And we've checked for extraneous solutions.